Python programming. So it is about semantic image synthesis of photorealistic landscape. So basically we are going to do is we are going to convert coloring segmentation mask into somewhat pseudo photorealistic landscape. So landscapes may include a natural grass, mountain, road, sky, and so on as listed in the toolkit. So let's have a demo about it first. So let us see a demo first. So let's first pop up an integrated terminal in the VS Code. It would basically open in the parent directory. Now we have to change the direct cd into the flask file, right? So there are two ways that you can run a flask server. One is flask run, other is just basically doing python app.py and then running. So it would basically run a development web development server with on a local host at the port we have defined, as in our case it's 5000. Let's just open it. So here we get the interface. We are given the options of the color palettes corresponding to the labels of the landscape that we want, a blank canvas, and here basically the generated image would pop up. So let us first paint it. So now let's just go on and hit the generate image button. So it would send a request here about the mask of it, like here the label tensor, and from that now our model would then output a generated image. Here we see that the generated image has been posted. Let us see. Yes, so this is our photorealistic landscape that has been generated. Okay, so let us now explore the code itself. So we would explore first the Flask Python API that we have been used. So here is the main program to run the Flask server, which is our app. So we create a Flask app that runs on the localhost itself. We then give two routes to it. One that is default that renders the index.html, and the second route is the generate route, which accepts a post request where we take the input label maps and then infer the label map itself, then generate a tensor that has been outputted by our model into an image, and that image, which is right now here, is an simple array of numbers, then is being converted to an actual image. That image is being transferred to our in memory, which is ram, that holds a file object, and that file object is being saved, and then image is being sent to the our index.html itself. So this was this. The evaluate function here comes from our test.py, where first of all the request that has came from the request.json is being transferred to the evaluate function, is being passed to the image array. Image is imported from PIL. It is a popular image holding library. The model is being initialized to the pixtwix model that we have been defined, that we would further look into it. The model is then set to the eval state. It is important as no training happens during this stage, and we don't want to change the gradients during the inference time, right? Then the image is being transformed to a transform label, so some normalization and rescaling is being done. Then the data is being passed after it to the model. There are three types of data in the data dictionary that we have passed. Generated label image that is of a shape 1 3 512 512 is being transferred, that is currently a torch.tensor, right? But then we have to convert it into an image, so we do a two image to it, and then which is being currently used in the app.py, the two image, and then we sent it to it, right? So this was the basic flask code that we have been using. So now let's look on to the model. So the model is basically a pix-to-pix model, that is the wrapper model that has been learned during the training of a generator model, and corresponding this is the PTH file, basically the checkpoint file for the discriminator, but we are only concerned with the generator model, right? So the pix-to-pix is a wrapper class for the net generator. The net generator is being created by loading the checkpoint of it and using pix-to-pix paired networks that are being initialized right here. First, the network is being created by here the in weights. Here a specialty is that the batch normalization is never initialized to something. It is initialized to a normal distribution of the weights. Like you here you can see the mean of the normal distribution is what we have defined, which is 1. The gain can be anything that we have defined, that is the deviation of it. Then Xavier distribution is being aligned to the weights, and hence the net has been loaded with the initialized weights. Further, the network has been loaded with other weights. The weights for convo layer, the learnable weights for some layers that are not patch norm in general. So it can be linear layers, dense layers, anything. So here the state generator. So let's go on to the network that is initializing the generator networks, which is here. So the spade network is basically a combination of ResNet blocks. The unique or the novelty in the ResNet blocks of spade are that we use a spectral normalization in spade. So rather than dynamic normalization of blocks in the same device itself, we perform normalization all over the device and not only in the channels that we provide. So yes, this was the generator blocks. Generator blocks basically first have the latent vectors generated, then the latent vectors are being interpolated using bicubic interpolation, and then further all the heads and all the upsampling is being done here. So here the image is being downsampled, and here it is being upsampled to generate the final image after a convo pass, after a real convo 2D pass, and final 10H activation function to the input tensor itself. Yes, so this was it. A quick note that ResNet blocks, res basically means residual blocks, right? So a residual blocks is basically fx plus x. So the output of an the layer itself is being passed to the original input. So the next input would be past input plus past output, right? So that's one thing we should remember. Now let's look on to the util functions. Some of the util functions that we have used is synchronized batch norms. So synchronized batch norms synchronizes the normalization technique to all over the device. So multiple channels can be synchronized at the same pace. Some other util functions to visualize can be to ONX model. So what we can do is that we can visualize the whole model into a net into a graph, a diacyclic graph. But in here the generator would be a single linear model itself. So we are in the govern directory, we would cd into the pre-trained model, right? So now let's load neutron app. Neutron is used for visualization of checkpoint networks, right? So Neutron is currently installed in the uh, torch environment. So let me activate it. And after that, we simply write neutron and then path to the network. So that's the latest net G, stands for generator.path. It would load a local host, and here we can see that it would load a neutron app